Hello students, today we learn about preparation of the warp yarns before weaving and also making of the draft plans, peg plans and also the denting plans required for weaving. The yarns that are intended for warp need to be processed in order to be used as warp yarns. Sometimes these yarns need to be more stronger than the weft, and so they are sometimes plied or given some more twist and then made ready for making into warp yarns. And generally these warp yarns are present on small spools and all, and they are wound on big spools, and then they have to be ready like this. And so they have to go through some of the operations like spooling, warping and slashing. So these operations are essential, but they do not improve the quality of the yarns. Then coming to the first operation, that is spooling, the yarns from various packages are being rewound and on big spools to facilitate the warping, and then they are placed on a rack called the creel. And so this creel will contain the spools which is having uninterrupted length of warp yarn, and generally this will depend upon the type of fabric that is going to be used or constructed from this particular warp beam. So during warping, the yarn from the big spools are drawn and they are placed on the warp beam side by side without any entanglement. So the yarn from all spools are placed one after the other, so that it results into a beam where there are more number of warp yarns being parallel to each other, and the number of these warp yarns depend upon the fabric and the fabric construction and the thread count, and the number of spools present over there should correspond to the number of the warp yarns that are required for constructing the particular fabric. Some of the factors to be seen while warping, or maybe these are the requirements, that the tension of the warp yarn drawn onto the warp beam should be similar or should be uniform, and it should constantly be drawn with the same tension throughout, so that there will not be any differences that come in the final fabric. Warping should not impair the mechanical and also the physical properties of the yarn. Then the surface packaging of the yarn should be cylindrical, so that there will not be any entanglement because of this. And then a predetermined length of the warp yarn should be drawn from all the spools in a similar way, and so that warp yarns will be there till the end of the fabric without any change. Then the production rate of warping should be as high as possible, and also if possible we have to also see that there should not be any faults in the yarns that are intended for warp, because warp yarns need to be stronger while weaving, because they are going to be on the loom throughout, and so they should be stronger than the weft yarns, because weft yarns are only inserted in between, and so only warp yarns required to be more stronger. Warping may be done manually in case of hand looms, and warping may be done with the help of machines in case of power loom fabrics. So different types of warping machines are in use today. These are all, principle may be different, but all of them will serve for the same purpose, that is preparation of the warp in the form of a warp beam. And there are machines like beam or a direct warping, which is used for the gray or monocolor fabrics, and there is sectional warping machines for stripes and check materials, and then we have also ball warping machines which are used for especially for the denims. These warp yarns are again passed through another operation called slashing. This is done generally to make the yarn to withstand the stress during weaving and also the abrasion resistance during weaving. Slashing bath may contain some starch, some resin or some gum, so that they will be coated on the material, and so that it temporarily gains some strength and also some abrasion resistance. And sometimes this also helps in removing the hair, that is it smoothens without much hair being seen on the, especially in case of spun yarns. And this particular slashing may also help in smooth running of these reed or heddles and all that. It can go through without any problem, smoothly it can go through. And abrasion generally happens at the eyes of the heddles or the heels, and also at the backrest and also at the dents. So, due to this slashing, the yarns are going to withstand the stress and also the tension during the weaving, and thus the fabric can be uniform throughout. So, the warp yarns from the initial warp beam are passed through the slashing bath, and then they are carefully wound on another warp beam to make it ready for weaving. And later the warp yarns are made to pass through the eyes of the heddles or the heels of shafts, and also through the dents of the reed as per the draft plan and denting plans specific to that particular weave. This is the most time consuming operation in case of handlooms and all, but due to the advancement in technology and all, the present looms, the power looms especially, and the warping is easily done, and with the help of microprocessors and all, and so it is very easy now to take it through the holes of the heddles and all, and as per the draft of the weave. And in case of weft yarns, these weft yarns are just simply rewound on small bobbins or cones that are to be placed in the shuttle later, and so to facilitate the weaving. For facilitating weaving, we have to come up with the draft plans and also peg plans and denting plans for each weave. Weaving is interlacement of two sets of yarns, namely the warp and the weft. So, interlacement of warp and weft yarns in various ways produce woven designs. Two kinds of interlacement is possible in this case, wherein the warp overlaps the weft, in which case the warp is seen on the surface of the fabric, and then weft overlapping the warp, in which case the weft is seen on the surface of the fabric. The construction of any woven fabric depends upon three basic elements such as weave design, the draft or drawing plan, peg or the lifting plan. The weave design, it is the design that indicates interlacement of warp and weft threads in the repeat of the design. There are two methods of representing these weave design, and which are linear and canvas methods. And in the linear method, the warp and weft threads are represented in the form of vertical and horizontal lines respectively. A dot near the intersection point indicates that there is a warp overlap, and if it is left blank, then it is a weft overlap is present. Even though it is a very simple method, but generally this is not employed because of the time consumption for drawing of the vertical and horizontal lines. In canvas method, a squared paper is taken, so that there is no need for drawing of this vertical and also horizontal lines. And in this each square space, the vertical space represent the warp yarns and the horizontal space represent the weft yarns. So, if there is any overlap of the warp, then it is generally indicated either by a dot or by a cross, or sometimes it is shaded. Wherever the weft yarn overlaps, it is left blank, so that wherever or some shaded spaces is seen, that means that there is a overlap of the warp, and so those warp yarns are seen on the surface of the fabric. Some people refer it as a weave diagram. And then coming to the weave repeat, it is a quantitative expression of any given weave. It indicates minimum number of warp and weft threads required for representing the interlacement of the warp and weft in a specific weave. The size of the repeat may be even or uneven based on the nature of the weave. The weave is even in case of the fundamental weaves such as plain, twill and satin, and it may be uneven in some fancy weaves like honeycomb and also huckaback and other types of fancy weaves. And then coming to the draft and drawing plan, this plan indicates the manner of drawing the ends or the warp-yarns through the heeled eyes, and it also denotes the number of heel shafts required to construct a fabric based on the weave repeat. So, the choice of the type of drafting plan depends upon the type of fabric woven. There are different types of drafts that are being used depending upon the weave and the fabric construction. The simplest of all is the straight draft. In this draft, the first warp in the design repeat is drawn through the first heel of the first shaft, and then the second warp through the second shaft, and the third warp through the third shaft, and so on till the last warp in the repeat is being completed. So, the number of shafts depend on the number of warps present in a weave repeat. The drafting order progresses successively from the first to the last shaft in the repeat. So, the unique feature of this draft is that the peg plan is same as the design, and so there is no need for separate peg plan for this particular straight draft. Then coming to another type of draft, that is pointed draft, and it is similar to a straight draft, wherein the straight draft is reversed after the half repeat warp way. So, the number of heel shafts used is about half the repeat size of the weave, and it is suitable for pointed twill, diamond weave and also ordinary types of honeycombs. And then skip and set-in drafts. The skip draft is suitable for weaving fabrics having heavy warp thread density. In this draft plan, the number of heeled frames may be twice or more than the minimum required size of a weave. The purpose of using more heels, heel frames than the minimum requirement is only to distribute the warp threads more uniformly so as to prevent abrasion of the threads due to overcrowding. The set-in drafts, it serves the same purpose as the skip draft, but a skip draft is usually normally employed for weaves such as plain and twill weave up to a repeat of 4. So, this set-in draft will be serving for repeats more than 5. Then coming to the broken draft, as the name indicates, it is similar to the pointed draft, but the pointed effect is being broken purposely and it is suitable for herringbone weaves. And then divided drafts. In the divided draft, as the name indicates, the draft is applicable for weaves having 2 sets of warp yarns such as terry weave or double cloth weave or warp backed weave, etc. In this draft, the face and back side yarns are divided into 2 groups, and the first group is for 8 heel shafts and then the second group for 9 to 12 heel shafts. And then coming to the group draft, these drafts are used for producing checked and striped fabrics. The draft is used for producing fabric with the 2 different stripes. So, the repeat of the draft is determined by the number of stripes and the number of threads in each stripe. The number of shafts depends on the number of stripes and the warp repeat weave of each stripe. Then coming to the curved draft, as the name indicates, here the progression of the warp yarns will not be in a line, and so it will be taken as a curve shape, and so the draft is applied for fancy weaves only with large warp repeat, and it is used to reduce the number of heel shafts, and curved drafts are irregular and cannot be classified. So, the minimal number of heel shaft equals the number of threads in warp repeat with a different order of interlacement. The drawing in is done applying the rule, that is, all warp threads which work alike are drawn on the same heel of shaft. Then coming to the combination draft, which is the most complex draft among all, because it combines various methods of drawing in, and for producing a certain type of fabric, maybe for a fancy weave, in the case of fancy weave and all, and it depends upon the design that is going to be produced through this weaving. So, two or more drafts which we have seen now are combined and can be applied simultaneously. And for example, a straight and skip drafts can be together or set-in drafts, and they can be grouped, and also some of the other things are like grouped and curved drafts can be combined, and so that it can give a altogether a different kind of fabric. So, it is a very complicated process as we thought of, and the designer must be really experienced in order to utilize this one for making of the fabrics. So, actually the shafts are being ready now with a number of warp threads that are being divided on different shafts. The how actually these should work should be known by only using the peg or the lifting plan, because for one interlacement one set of warp yarn should be raised and the other set should be lowered, then only interlacement will take place. So, this peg or lifting plan indicates the selection of heels to be raised or lowered on each successive insertion of the pick or the weft yarn. In a peg plan, the vertical spaces indicate the heel shafts and the horizontal space indicates the picks or the weft. The peg plan depends upon the drafting plan, and in case of a straight draft, the peg plan will be the same as the design, and so separate one is not required. The process of inserting warp threads or ends through the dents of a reed is called as denting, and the plan on the order in which denting is done is called as the denting plan. So, the most frequent order of denting may be 1 per dent or 2 per dent, 3 per dent or 4 per dent, and usually 2 yarns per dent is generally found. And for some of the fancy weaves and all, irregular denting can also happen, because sometimes some of the warp yarns need to come up or down in order to facilitate a fancy weave, and so as per the construction of the particular weave, and more number of yarns may be placed unevenly, not evenly, unevenly, they may be placed through the dents of the reed. Thus, the warp yarns are made ready for weaving, and generally they are taken from the warp beam and they are passed through the eyes of the heeled shafts and also through the dents of the reed, and then they are passed on to the cloth beam, and wherein they are tucked over there, and thus on the loom when we see the warp yarns are seen on the loom and extended between the cloth beam and the warp beam to facilitate the weaving process. The weave may be simple or complex, or it may be with extra set of warp yarns or extra set of weft yarns. All weaves require warp yarns, and all warp yarns need to be prepared like this in order to facilitate the weaving process.